Organizational architecture has two very different meanings. In one sense it literally refers to the organization, its built environment, and in another sense it refers to architecture metaphorically, as a structure which fleshes out the organizations. Organizational architecture or organizational space, the influence of the spatial environment on humans in and around organizations. Organizational architecture or organization design, the creation of roles, processes, and formal reporting relationships in an organization. Organizational space describes the influence of the spatial environment on the health, the mind, and the behavior of humans in and around organizations. It is an area of research in which interdisciplinarity is a central perspective. It draws from management, organization and architecture added with knowledge from, for instance, environmental psychology, social medicine, or spatial science. In essence, it may be regarded as a special field of expertise of organization studies and change management applied to architecture. This perspective on organizational architecture is elaborated in organizational space. Organization design or architecture of an organization as a metaphor provides the framework through which an organization aims to realize its core qualities as specified in its vision statement. It provides the infrastructure into which business processes are deployed and ensures that the organization's core qualities are realized across the business processes deployed within the organization. In this way, organizations aim to consistently realize their core qualities across the services they offer to their clients. This perspective on organizational architecture is elaborated below. Content. According to most authors, organizational architecture is a metaphor. Like traditional architecture, it shapes the organizational space where life will take place. It also represents a concept which implies a connection between the organizational structure with other systems inside the organization in order to create a unique synergistic system which will be more than just the sum of its parts. Conventionally, organizational architecture consists of the formal organization, informal organization, business processes, strategy and the most important human resources, because what is an organization if not a system of people? The table shows some approaches to organizational architecture. The goal of organizational architecture is to create an organization which will be able to continuously create value for present and future customers, optimizing and organizing itself. Some under organizational architecture understand building blocks which are mandatory for the growth of the organization. To design an organization means to set up a stage where the drama of life will take place. Design. Organization design can be defined narrowly, as the process of reshaping organization structure and roles, or it can more effectively be defined as the alignment of structure, process, rewards, metrics and talent with the strategy of the business. Jay Galbraith and Amy Cates have made the case persuasively that attention to all of these organizational elements is necessary to create new capabilities to compete in a given market. This systemic view, often referred to as the star model approach, is more likely to lead to better performance. Organization design may involve strategic decisions, but is properly viewed as a path to effective strategy execution. The design process nearly always entails making trade-offs of one set of structural benefits against another. Many companies fall into the trap of making repeated changes in organization structure, with little benefit to the business. This often occurs because changes in structure are relatively easy to execute while creating the impression that something substantial is happening. This often leads to cynicism and confusion within the organization. More powerful change happens when there are clear design objectives driven by a new business strategy or forces in the market that require a different approach to organizing resources. The organization design process is often defined in phases. Phase 1 is the definition of a business case, including a clear picture of strategy and design objectives. This step is typically followed by strategic grouping decisions, which will define the fundamental architecture of the organization, essentially deciding which major roles will report at the top of the organization. The classic options for strategic grouping are to organize by behavior, function, product or category, customer or market, geography, matrix. Each of the basic building block options for strategic grouping brings a set of benefits and drawbacks. Such generic pros and cons, however, are not the basis for choosing the best strategic grouping. An analysis must be done completed relative to a specific business strategy. Subsequent phases of organization design include operational design of processes, roles, measures and reward systems, followed by staffing and other implementation tasks. The field is somewhat specialized in nature and many large and small consulting firms offer organization design assistance to executives. Some companies attempt to establish internal staff resources aimed at supporting organization design initiatives. There is a substantial body of literature in the field, arguably starting with the work of Peter Drucker in his examination of General Motors decades ago. Other key thinkers built on Drucker's thinking, including Galbraith, Nadler, Ale and Lawrence and Lorsch. Organization design can be considered a subset of the broader field of organization effectiveness and organization development, both of which may entail more behaviorally focused solutions to effectiveness, such as leadership behaviors, team effectiveness and the like. Many organizational experts argue for an integrated approach to these disciplines, including effective talent management practices. There are various approaches to organizational architecture including 1986, 1991, 2004, Kenneth D. McKenzie, 1992, 1993, David Nadler and Michael Tushman. Organizational Architecture, by David Nadler, Mark Siegstein and Robert B. Shaw. 1993, 1995, Designing Organizations Using the STAR Model as developed by J. Galbraith, Benjamin's Layered Model of Organizations. The Organizational Adaptation Model by Raymond E. Miles and Charles C. Snow. 1995, Richard M. Burton and Baad G. Ovell, 2004, Richard K. Daft, 2001, Ralph Kilman, 2005, The Trichord Model, Designing Organizations from a Whole Systems Perspective, Characteristics of Effective Organizational Design. Some systems are effective and efficient whereas others are not. Successful systems may be attributable to the skill exercised in designing the system or to the quality of management practiced during operations, or both. Successful systems are characterized by their simplicity, flexibility, reliability, economy, and acceptability. Simplicity, flexibility, and reliability tend to be a function of design, whereas economy and acceptability pertain to both design and operations. Numerous relationships exist among these characteristics. For example, simplicity will affect economy and possibly reliability. Moreover, management must reach a compromise between economy and reliability, and between technical efficiency and organizational climate. The balance reached will determine whether short or long-run objectives are optimized. Simplicity, an effective organizational system need not be complex. On the contrary, simplicity in design is an extremely desirable quality. Consider the task of communicating information about the operation of a system and the allocation of its inputs. The task is not difficult when components are few and the relationships among them are straightforward. However, the problems of communication multiply with each successive stage of complexity. The proper method for maintaining simplicity is to use precise definitions and to outline the specific task for each subsystem. Total systems often become complex because of the sheer size and nature of operations, but effectiveness and efficiency may still be achieved if each subsystem maintains its simplicity. Flexibility, conditions change and managers should be prepared to adjust operations accordingly. There are two ways to adjust to a changing operating environment: to design new systems or to modify operating systems. An existing system should not be modified to accommodate a change in objectives, but every system should be sufficiently flexible to integrate changes that may occur either in the environment or in the nature of the inputs. For example, a company should not use the same system to build missiles as it uses to build airplanes, nor the same system to sell insurance as the one originally designed to sell magazines. However, it should be possible to modify an existing system to produce different sizes, varieties, or types of the same product or service. A practical system must be well designed, but it cannot be entirely rigid. There will always be minor variations from the general plan, and a system should be able to adapt to such changes without excessive confusion. The advantages associated with having a flexible system will become more apparent when we consider the difficulty of administering change. Reliability. System reliability is an important factor in organizations. Reliability is the consistency with which operations are maintained, and may vary from zero output to a constant or predictable output. The typical system operates somewhere between these two extremes. The characteristics of reliability can be designed into the system by carefully selecting and arranging the operating components. The system is no more reliable than its weakest segment. When the requirements for a particular component such as an operator having unique skills are critical, it may be worthwhile to maintain a standby operator. In all situations, provisions should be made for quick repair or replacement when failure occurs. One valid approach to the reliability maintenance relationship is to use a form of construction that permits repair by replacing a complete unit. In some television sets, for example, it is common practice to replace an entire section of the network rather than try to find the faulty component. Reliability is not as critical an issue when prompt repair and recovery can be instituted. Economy. An effective system is not necessarily an economical system. For example, the Postal Service may keep on schedule with mail deliveries but only by hiring a large number of additional workers. In this case, the efficiency of the postal system would be reduced. In another example, inventories may be controlled by using a comprehensive system of storekeeping. However, if the cost of the storekeeping were greater than the potential savings from this degree of control, the system would not be efficient. It is often dysfunctional and expensive to develop much greater capacity for one segment of a system than for some other part. Building in redundancy or providing for every contingency usually neutralizes the operating efficiency of the system. When a system's objectives include achieving a particular task at the lowest possible cost, there must be some degree of trade-off between effectiveness and efficiency. When a system's objective is to perform a certain mission regardless of cost, there can be no trade-off. Acceptability. Any system, no matter how well designed, will not function properly unless it is accepted by the people who operate it. If the participants do not believe it will benefit them, are opposed to it, are pressured into using it, or think it is not a good system, it will not work properly. If a system is not accepted, two things can happen. 1, the system will be modified gradually by the people who are using it, or the system will be used ineffectively and ultimately fail. Unplanned alterations in an elaborate system can nullify advantages associated with using the system. Differentiation and integration. A basic consideration in the design of organizations is dividing work into reasonable tasks while giving simultaneous attention to coordinating these activities and unifying their results into a meaningful whole. Two guidelines may be followed in grouping activities. Units that have similar orientations and tasks should be grouped together. Units required to integrate their activities closely should be grouped together. When units neither have similar orientations nor share their activities, the task of grouping becomes more difficult. For example, when units are similar in nature and function but are also relatively independent, the manager must base his decision on the most appropriate way to group activities according to his past experience. A difficult task associated with system-subsystem determination is to establish proper boundaries of operations. The more specific and distinct the goals of the operation, the easier it is to set boundaries. Other factors such as the influence of the environment, the availability of men and machines, the time schedule for design and operation, the cost of alternative designs, and the particular biases of the designers must be considered when establishing boundaries. The role of management. Designers with imagination have the best chance to group people and machines into workable combinations having the greatest efficiency and effectiveness within the recognized constraints. Certain characteristics should be designed into an effective and efficient system: simplicity, flexibility, reliability, economy, and acceptability. At this point, the designer must determine what has to be done to achieve the stated objective, S, and how the total task can be divided into meaningful units. Of the many possible combinations, one must be selected as that which satisfies the decision criteria better than the other alternatives. Of course, the balance between technical efficiency and the human factors that determine organizational climate should be included in making this decision. The eventual success or failure of the project is somewhat predetermined by management's attitude and the relationship between the designers and those who must implement the process. The systems approach suggests a new role for management. In the traditional view, the manager operated in a highly structured, rigid system having well-defined goals, clear-cut relationships, tight controls, and hierarchical information flows. In the flexible systems view, the organization is not static but is continually evolving to meet both external and internal changes. The manager's role is to develop a viable organization, cope with change, and help participants establish a dynamic equilibrium. Leonard Sales has expressed the manager's problem as follows: the one enduring objective is the effort to build and maintain a predictable, reciprocating system of relationships, the behavioral patterns of which stay within reasonable physical limits. But this is seeking a moving equilibrium, since the parameters of the system are evolving and changing. Thus, the manager endeavors to introduce regularity in a world that will never allow him to achieve the ideal. The systems approach does not offer a prescription for making a manager's difficult and complex job easier. Rather, it helps him understand and operate more effectively within the reality of complex systems. The systems approach suggests that operations cannot be neatly departmentalized but must be viewed as overlapping subsystems. In addition, it suggests that leadership patterns must be modified, particularly when dealing with professionals and highly trained specialists, and motivation must take the form of active, willing participation rather than forceful subjugation. Systems design involves establishing project and facilitating subsystems to accomplish certain tasks or programs. In this approach, the network of human independence required to accomplish a given task is based on the shared responsibility of all members of the subsystem. In contrast, the traditional organization is geared to functional performance and the integrating force is authority. Instead of gearing participant activities to obedience to rules and closely structured behavior, the systems approach provides a basis for active cooperation in meeting task requirements. The manager is looked upon as a resource person who can help the group meet its goals and also as a source of authority and control. Thus, systems theory lends a structure by which the concepts of motivation, leadership, and participation can be applied effectively within the organization. Implementation is, of course, implicit in the connotation of systems design. Otherwise it would be nothing more than an empty exercise. It follows that the interface between managers and systems designers is critical, and mutual understanding must be fostered to maximize returns from design efforts. The system must be tailored to the needs of the organization and adapted continually as circumstances change. In a general sense, managers engage in systems design on a day-to-day basis when they plan activities and organize systems to accomplish objectives. Specialized staff groups have evolved to perform tasks such as long-range planning, organizational studies, and systems design. However, since managers are ultimately responsible for organizational endeavors, they should make a special effort to help ensure the development of useful systems and to make design activities an extension of the manager's role rather than a separate function. Operating managers need to understand the organizational decision-making requirements and the information needed to support the system. Although the probability of success in implementation is enhanced considerably if management is vitally interested in the project, technical expertise and motivation for change are more likely to be found in staff groups. The solution to the apparent dichotomy would seem to be a team approach, with specialists supporting operating managers who are responsible for the project's success. A manager might devote either part-time to such an effort or full-time temporarily, if the task requires it. A project involving an integrated system for the entire company might well require years to complete. If operating people are delegated responsibility and authority for such a project, particularly if they are delegated the authority to outline specifications, they should also maintain sufficient contact with the day-to-day operations and its attendant information flow to retain their expertise for decision-making. If the environment is dynamic or internal capabilities undergo change, it might be wise to rotate people from operations to systems design periodically, so that operating expertise is updated continually. See also, organizational design, organizational structure, departmentalization, enterprise architecture framework, interdisciplinary center for organizational architecture, view model, references. Further reading, The Spaces of Organization and the Organization of Space Power, Identity and Materiality at Work by Karen Dale and Gibson Burrell, 2008, ISBN 0-230-57268-5, Inorganicity van Vlies en Steen by Mark Mobach, 2009, ISBN 978-90-232-4531-5, Organization Modeling by Joseph Murabato, Ira Sack and Anil Kumaput, 1999, ISBN 0-13-257552-3, Designing Organizations. By J. Galbraith, Jossey Base Publishers, San Francisco, 1995. A Framework for Managing IT-Enabled Change by R. I. Benjamin and E. Levinson, Sloan Management Review, Summer 1993. Organizational Architecture by David Nadeler, Mark Siegstein and Robert B. Shaw, 1992, ISBN 1-55542-443-0. Architectura Suvremenny Organizacja by Miroslav Angstrom 1/2 Ugorjan Marcus Shatton, Publisher Tonomir, Bearer 3/4 Dinsk Toplice, 2005, ISBN 953-7069-50-8, Organizational Adaptation by Raymond E. Mulls and Charles C. Snow, 2003, ISBN 0-8047-4840-3. Burke Lightwin Model of Organization Performance by W. Warner Burke and George Lightwin, Journal of Management, Volume 18, No. 3, 523-545, The Design Way by Harold G. Nelson and Eric Stolterman, ISBN 0262018179, ISBN 978-0262018173.